Okay, I wanted to start with problem number 20, Bayes' theorem, just to kind of show you that it's not as bad as the formula looks. First of all, if you look at Bayes' theorem, you'll see the formula, and you can write the formula down, but this is the probability of A and the probability of B given A, okay? And then you have event A2, and we'll talk about that as well. But I'll just kind of sum that up as we work this problem. So what you need to do is see that retailer A gives 64% of the DVDs, retailer B gives 36%. So A is 64% of DVDs, B is 36%. And then 9% of the DVDs from A are defective, and 8% of the DVDs from retailer B are defective. So remember, retailer A is 64%. Of those 64%, 9% are defective. Retailer B is 36%. Of those 36%, 8% are defective. And we want to know the probability that the DVD came from the defective DVD came from retailer A. So what I would do is I would first define my probabilities. We have two events. One event is A1, and A1 is the probability that it's purchased from retailer A. And then we have what we call A2, and that's the probability that it is purchased from retailer B. And then we also have the probability of B, given that it's from A1. B is the probability that it's defective. So if it's getting from A1, it's the probability that it's defective, and then the probability of B, A2, is the probability that it's defective. I guess you could kind of put, if you wanted to, defective from A1 and then defective from A2, so you have to look at that. So the probability that it's purchased from retailer A, I believe, was 0.64, and the probability that it's purchased from retailer B was 0.36, and the probability that it is defective, given it is purchased from retailer A, is 0.09. And the probability that it's defective, given it is purchased from retailer B, is 0.08. So basically your formula, and I'm just going to punch in the top. The top would be the probability of A1, which is 0.64, times the probability that of it being defective, given it came from A1, which is 0.09. Now, the bottom, I will give you a big hint. Whatever you put on the top will be the first thing you put on the bottom. So 0.64 times 0.09. That's all to do with the one that you're trying to find. We're trying to find the probability that the defective DVD was purchased from A1. Now, the next part is the probability of A2, which is 0.36. Times the probability of B happening, given that it came from A2, which would be 0.08. All right. Now, that is your formula. What I'm going to do is I'm going to put equals here. Actually, I'll just do it down here. Equals 0.08 0.64 divided by 0.09, 0.64 times. And then the bottom would be this. Let's put equals. May not let us do that. So let's just do equals 0.64 times 0.09 plus 0.36 times 0.08. Let's do this. I did parentheses instead of, okay. So that would be your numbers, and then we would say this, you could do this in the calculator, I'm just doing it on Excel. So your probability that the defective DVD came from retailer A is 0.67. So this is the formula. It's really not that bad. This, whatever if you can figure out what goes here, it goes down here too, and it's always the probability of what you're trying to find. And then over here is the probability of B given A2, which is the one we're not trying to find. Let's look at the next one. The next one is the same thing basically, except we have 3 different scenarios. So we have bonds, and we have R1, R2, and R3. 50% were rated R1, 40% were rated R2, and 10% were rated R3. Out of these bonds, 40% were issued by the city of R1, 50% of R2 were issued by cities, and 60% were issued by cities of R3. We want to use the Bayes theorem to compute the probability that the new bond is to be issued by a city. It will receive an R1 rating. So basically, we are going to do the same thing. We're going to call R1 A1, and then we're going to have A2, and then we're going to have A3. And then we're going to have the probability of B given A1, the probability of B given A2, and the probability of B given A3. Now, we know the probability of it being an R1 bond was 0.5, and then the probability of it being an R2 bond was 0.4, and the probability of it being an R3 bond was 0.1 or 0.10. And then B is the probability that, if we look back at it, the probability out of these 40% of R1 bonds were issued by cities. So 40% of R1 bonds were issued by city, and then 0.5, and then 0.6. Now this time we're looking at the R1 or the A1 bond. So the probability of A1 is 0.5. Let's do this. Let's put everything in parentheses so I can see what's going on here. Times the probability of a bond being issued given it was A1 would be 0.40. So that's all that goes on the top. And then we're going to do the same thing on the bottom. We're going to just repeat that. And then we're going to go straight to the next bonds. So our 2 bonds, there are 0.4 of them. 0.4 of the bonds were R2, and given that they were R2 bonds, the probability of them being issued was 50%. Now we're going to do R3 bonds. So now we have 3 things instead of 1, but we know R3 is the 0.1%, and given that it is a bond, 60% chance that it would be an R3 bond, and those are your numbers. Okay? And then all you have to do is multiply those. I'm just going to try to do this without being crazy this time. Okay, and then down on the bottom. So we get 0.2 divided by 0.46, and if you do that, you get 0.435. That rounds to 0.435. That is basically Bayes' theorem summed up. If you kind of get the flow of it, what you're trying to find, the probability of it, the total amount of the bonds being issued over here times the probability of that bond. If you pair them up together, it's really not that bad.